Dear colleagues, our research was carried out with the aim of theoretical generalization of modern network technologies and their best application in modern and future smart cities. The human environment and urban infrastructure development face similar challenges. Today, one of the most pressing tasks of the Smart City project is the best network technologies choice. The main task of our scientific work is to study and promote the development of the Smart City project. The most important goals are identify factors that affect the project success, select existing network and IoT technologies, and propose an optimal technological solution. The plan of our study is to consider the main components and possible solutions for the smart city networks. The modern smart city network is based on two main components, the Internet of Things and high-speed wireless network. The first assumes a wide address space and a wide variety of network devices. The second requires a high level of protection and security, computing resource allocation, high data transmission, simple network management, and support. We will try to address all these problems here. One of the most relevant technological solutions for IoT is the low-power wide area network. Wireless technology, which is a wireless network with low energy cost. Radius network is about 1-2 kilometers. A stable signal is expandable up to 4 kilometers without significant obstruction. The low energy consumption of the sensors used in the network. LoRa technology is the best way to implement the Internet of Things, both domestic and industrial. The Internet of Things use small sensors that transmits a small amount of information over a period. LoRa sensors have a good information transmission protection with symmetric encryption and a common range of frequency tuning, which is reflected in the reliability of the signal. Sensors will fully meet modern industry needs in collecting information. LoRa technology combines the possibility of use in a wide range of applications and the ratio of maintenance costs and the deployment of scalable networks. Our research has shown that RFID technology is the most suitable technology for monitoring mobile objects in a smart city. The use of active RFID tags allows offline monitoring of mobile objects' behavior at a distance up to 300 meters from data collection points. This makes it more competitive compared to similar technologies such as Bluetooth Low Energy. Despite the existing technological barriers to the global transition from IPv4 to IPv6, the number of IPv6 devices is constantly growing. Modern statistics indicates that up 25% of the global volume of Internet access devices are connected to the network using IPv6. We came to the conclusion that IPv4 is one of the inhibiting factors for the development of smart city networks. A full transition to IPv6 can solve this problem. IPv6 deprives the network of certain IPv4 bottlenecks, such as network address translation, virtual local area network, etc. IPv6 simplifies a network security policy with a reduction to use of AAA protocol and multi-level firewalls, transfer of security under the control of the network operating system. IPv6 addressing allows to structure addresses by geographic location. The main problem is that IPv4 requires maintaining backward compatibility in building networks, so the transition requires large financial investment. Hundreds of new smart cities are currently under construction. The only solution for them is to choose IPv6 addressing initially. Now, there are two possible technologies for smart city high-speed wireless network, WiMAX and 5G. Modern research 5G do not give yet possible to fully assess its global use. We took a generalized evaluation for comparison. In our opinion, a large flow of media data, guaranteed quality of service, and low power consumption are the most essential characteristics of smart city network. That is why 5G is the best solution. Modern computer networks have many disadvantages. It's a constant need to optimize the information flow, complex security organization, a large number of protocols to be integrated in the setup. All it needs improvement and organizing simplification. We see a solution to this problem in software-defined networking technology, SDN. SDN management mechanism is placed on a separate software base. SDN controller determines the network management rules based on a real-time events. The open flow protocol switches in a flow tables containing information about where, how, and what traffic to pass. SDN controller actually centralizes the intelligent functions of firewall, IP security, and other common network security systems. The proposed technical solution takes into account the fact that IPv6 addressing allows you to structure addresses by geographic location. The solution is to use IPv6 geography not only to identify the city, but also to determine the area or neighborhood. Each 5G signal propagation zone has its own radius, within which addresses of certain range are used, which is reserved for geographical affiliation, and example of which can be a residential city block. 5G provides a low energy requirement and introduces the possibility of implementing many technical innovations, such as augmented reality and others that require high data rates of large amounts of data in a short period. The urban network should focus on the SDN. This creates great advantages, making the network flexible and distributed. The network does not require large resources to manage. The Internet of Things can be embodied in the full range of industries and reproduction prospects. Smart transport, smart buildings, communication with industry, web crawling things with artificial intelligence. Radio frequency identification allows geographic identification of smart city objects. A quality of service is ensured, which makes it possible to work with a large amount of high-quality media traffic. The proposed network implementation options for the smart city project is a city-specific software-defined wireless 5G based network with LoRa technology leading and RFID for identification of communication devices. The proposed network model is able to solve all the relevant problems in this area with a single universal technical solution. Thank you for your attention.